This example comes out of section 7.3, solving exponential equations. So this is a follow-up to our last compound interest example where we were investing $6,000 into an account that earned 5.64% annual interest. This time we're compounding it quarterly, and this time we're not told for how long. We're asked how long will it take to go to $9,000. So maybe you're trying to save up for a nice used car or something like that, and or a relatively nice used car, nicer than mine. And so you do start with the same compound interest formula, and again remembering that A is your final amount. So in this case we were given A, we're given the principal, and we have the interest rate, but we're not going to get 0.0564 on our investment every quarter. We're getting a quarter of that. And n, if I define n as my number of compounding periods, I just leave it as it is. If I defined n as my number of years, I'll have to be a bit more careful and put 4n as the exponent. But if n is just the number of compounding periods, which is what we've left it as in our previous example, I'm basically taking this question and solving for n. Now, unless you've worked ahead into chapter 8 or have some previous experience that I don't know about, you don't know how to do this one algebraically yet, because it does require logs to get that n down from there. So what I would expect that you would do in a question like this is solve it graphically. So we're looking to graph the left side of the equation and graph the right side of the equation. So 6,000 times, and maybe you want to take a second and figure out what 0.0564 divided by 4 is. 1.0141, and on your calculator the n needs to look like an x. And your calculator will draw for you one curve that's growing exponentially and one horizontal line that looks something like that. And you have one point of intersection. So your window settings is something you need to include here. And if you make your window go at least somewhere up past 9,000, 10,000 maybe on the y values, your x values, you'll find that your window better at least go past about 30. So if you make it go to 30, that's good enough. If you make it go to 50 or something like that, it would be good. Your intersection here, if you do second trace intersect, you get that x is approximately 28.96. Now it is important that we know what x is, because if we just say it'll take 28.96, the person will say 28.96 what? It's not 28.96 years. In fact, that would be way too long. You'd have much more money in this investment after 29 years than you would more than $9,000. What this is 28.96 compounding periods. The fact is you have to round this, because 28.96 compounding periods wouldn't really happen. They either compound your interest or they don't. And so you would need to round this. It doesn't make sense to round it down to 28, because after 28 compounding periods you would not have enough money. You wouldn't have the $9,000 for the used car. So if I round it up, we're going to round it to 29 compounding periods. And so that would be one way to give your answer. Each compounding period is a quarter of a year. So if I said 29 divided by 4, it gives me 7.25 years. So that would be probably a more common answer for somebody to say, how many years is it going to take for this to happen? 7.25 years. 7 years, after 7 years, you wouldn't quite have enough money to buy your car. You don't have to wait 8 years, because they are compounding it every quarter, so it would be 7.25 years, 7.25 years would be the answer to this question. You'd have just over $9,000, so you might be able to buy yourself a coffee to go with your car.